For the last lesson of Unit 8, we are going to be doing a lot more with some more vocabulary and some more applying those vocabulary words. So for the first one, our learning goal, we're going to be able to do 3 things. First of all, you're going to be able to, when we're done with this, find multiples of given numbers. The second thing you'll be able to do is answer problems involving square roots, and we'll talk a lot about what that means later in the video. And the last one, compare prime and composite numbers. So by the time we're done, hopefully you'll be able to do those 3 things. So the first one, finding multiples. We're going to actually compare factors to multiples because a lot of times they're mixed up. So when you think about factors, like we talked about in the last video, factors are smaller than the given number. They're numbers you multiply to get the number. So multiply these to get a given number. So for example, an example of a factor might be the factors of, let's say, 12 would be 1 and 12, 2 and 6, 3 and 4. So those are the factors. Now, if you're working with multiples, multiples are larger than the given number. When I think multiples, it reminds me to multiply. And our multiplying is just like we're skip counting by certain numbers. So our example here, let's say we had, let's do 6 for example, as an easy one. So multiples of 6 would be anything you multiply 6 by. So 6 times 1 is 6, times 2 is 12, 18, 24, and so on. So these are all considered multiples of 6 because you multiply 6 by something to get to them. So now I'm going to give you a number and I want you to find the factors and the multiples of them. So I want you to find the factors of 8 and the multiples of 8. And I want you to list all the factors. And for the multiples, I'd say list the first 6, just to be on the safe side. Then when you're done, I want you to circle the least common multiple. And for your reference here, so if up here I had the multiples of 6, if I do the factors of 6 here too, we'd have 1, 6, 2, and 3. So if I wanted to find my least common multiple, I would look at, if I had factors of 6 and factors of, let's say, 4, 8, 12, 16, 20, and I wanted to find the least common multiple, I would look for what smallest number they have in common. So that would be 12 and 12. So list the factors, list the multiples. Then, after you finish that, come down here, list the multiples of 10 and the multiples of, let's say, 7, and find the least common multiple to circle. So I'm going to be looking for you to answer these ones find the factors and multiples. Then I want you to find the multiples only here and then circle the least common one. The next thing we're going to do is jump down to, if we look back up at our learning goals, this was number 1, and hopefully we've accomplished number 1. You can find multiples. I'm going to skip ahead actually now to number 3. So number 3, we are going to compare prime and composite numbers. So you can see we've got another T-chart here. We've got prime and we've got composite. So these are actually quite easy to remember. For a prime number simply is any number that has only 2 factors. Has only 2 factors. And the factors of a prime number are 1 and then itself, whatever the number is. So for example, the number 5, the only thing that 5 can be divided by is 1 and itself, where you would get a whole number. A composite number has more than 2 factors. So if a number is prime, it's not composite. If a number is composite, it can't be prime. They're opposites. So if you know your prime numbers, everything else is a composite number. So an example here might be the number 6, because 1 and 6 are 2 factors, but so are 2 and 3. So that's the only difference between prime and composite. So I want you to give me, on this side, 2 examples of prime numbers, and I would like 2 examples of composite numbers. So go ahead and write those down, and then flip your paper over because we're going to take some notes on the last part. Alright, so on the back of your paper we're going to talk about the last learning goal, which is talking about something called square roots. Now I'm going to pull up a web page that I want you to take a look at, and you don't need to pull it up on your own, but it does a really good job explaining and visualizing what square roots really are. Alright, so if you take a look at this, you can see a square root is the square root of a number is a number when multiplied by itself gives the original number. That sounds very wordy. Basically, it's any number multiplied by itself. So if you were trying to find the square root of 9, for example, you are thinking what number times itself would equal 9. And this is the symbol for a square root. So when you are on your paper, I want you to go ahead and write the definition that we had up here, which was a number multiplied by itself giving an original number. So a number multiplied by itself to give you the original number. So basically anything times itself equals a number. And this then, as long as these are the same thing, would become the square root of this. So the way that you would show this is you would make a straight line and then a check mark and then another line straight across. And then the number that goes underneath that, sort of like a division symbol, that's what you're trying to find the square root of. So if I had the square root of 4, that's like saying what times itself gives you 4? The answer in this case would be 2. 2 times itself. If I had the square root of 9, for example, what times itself gives you 9? Well, the answer is 3. So I'm going to flip back here, and feel free to take notes on this webpage, but I want to show you some of these different numbers. So if I put in 2, it shows you 2 times itself. 2 times 2 is 4. So the square root of 4 is equal to 2. If I put in 3, 3 by 3 equals 9. So if 3 is my number here, that's the answer to the square root of 9. I put in 4. I'm just going to keep showing you these so you can see it's 4 by 4. What times itself, you know area, equals what bigger number? I put in 5. The square root of 25 is 5. I'm just showing you these so you can get a visual of how this works. These are also called perfect squares because they are identical length and width. So when you have something where the length times the width is exactly the same, you could find the square root of the area to find either the length or the width. Square root of 8, square root of 9, square root of 10, and that's as high up as this website goes, but you can hopefully start to see and visualize what times itself gives you this big number. So if I said the square root of 100 is what times itself. It's not 50 times 2 because 50 and 2 are different numbers. So that is square root in a nutshell. So I am going to have you do maybe one more quick practice and then that'll be it for today. So I'm going to have you try, and I want you to write this in so you can practice writing the square root sign. But the square root of, let's say, 25 is, remember, it means what times itself. So go ahead and fill that in and then be ready to turn this in tomorrow. Good luck.